couple more things I want to point out while I've got the Hertz meter hooked up. The red and green terminals there are both attached to the same wood screw, which is also attached to one of the windings on the coil of the oscillator. And that's also, incidentally, where the Hertz meter is hooked up right now. The positive to the red there and the negative to the green, which is the negative post of the battery receiving the load, or being the load and receiving the charge. But if I were to take the black and the red leads and touch them to each other, the Hertz reading would be 0. And also, if I touched both leads to that screw, it would still say 0. So it shows that the reading that it is picking up is happening in the batteries, and the battery is part of the circuit that is actually causing this resonant frequency to show up on the meter in the first place. Okay, the other thing is the fact that it lingers after I take it off. So I'm going to disconnect the power supply and drop the lead. Okay, I'm going to hook the meter back up to it, and look, the frequency actually goes up a bit, and the wheel is still spinning, but you hear the clicks aren't there anymore. The attractive force supplied by this battery in that coil is no longer accelerating the wheel and maintaining its momentum, so it's slowly slowing down, but see, the magnets are still passing over that iron, and that field is still being set up such that frequency is really jumping around there and going up. As the wheel slows down, in a way, it's just going to keep on going. And so this battery is still resonating as a result of these magnetic pulses. And when the wheel comes to a final stop, which I'm going to go ahead and just stop it, and then the meter goes to 0. Give the wheel a little spin by hand without attaching the battery to the circuit. There's the frequency again, showing right back up again. That I thought also was an interesting thing.